Okay, look, a lot of us really love our gas stove, but they're kind of awful for your health. Chill, we're happy, we're talking about gas. Gas stoves burn natural gas, which is mostly made up of methane along with ethane, butane, propane, and pentane. Now, if you were just burning those hydrocarbons, combusting them with oxygen, you would expect that your stove would just produce carbon dioxide, water, and heat. But gas stoves give off way more than just carbon dioxide and water. Gas stoves can also give off small amounts of things like carbon monoxide and formaldehyde, as well as particulate matter, which can get way down into your lungs and cause or exacerbate lung and heart problems. Research has shown that homes with gas stoves can have 50 to 400% higher concentrations of nitrogen dioxide than homes with electric stoves. And unfortunately, while the EPA regulates air quality outside your house, it doesn't regulate the air quality inside your home. So it can just get real gross. This means the indoor air pollution level could reach levels that would be illegal outdoors. One study compared peak indoor air pollution levels while cooking a large meal like Thanksgiving to those found in some of the world's most polluted cities like Delhi. They found that those peaks were just as bad as the outdoor air in some of those cities, though they were thankfully very short-lived peaks. One of the ways that cooking in general causes indoor air pollution is through particulate matter. Literally tiny particles of stuff that can float around in the air when you cook. Heating food generates small particles of things like fat that float on up into the air and then into your lungs. One of these kinds of particles is PM2.5, which stands for particulate matter 2.5. These are just like they sound. They're tiny particles less than 2.5 microns in diameter. That is 4 times smaller than most dust particles. Because they're so small, they can travel deep into your respiratory tract, which is gross. Cooking with gas also produces a type of contaminant known as ultrafine particles. These are even smaller, as small as 2 nanometers, 1,000 times smaller than PM2.5. The particulate matter produced by cooking can vary based on lots of factors. The temperature that you're cooking at, the type of cookware or fat that you're using, how much you're stirring, the list goes on. But the bottom line is that cooking produces particulate matter, and you probably want to think about how you can reduce the amount of just like debris that you're breathing in when you're cooking. So this all made me really curious just how disgusting my kitchen is when I'm cooking. So I wanted to do a little demo to look at how much particulate matter is produced in my apartment when I cook. Is this a balanced and even experiment between gas and electric stoves? Absolutely not. No. For that, I would need a much nicer detector, lots of replicates, and an electric stove to compare it to. But I cook a lot, and after doing all this research, I just want to see what's happening in my kitchen. For each of these tests, I want to keep them pretty controlled, so I'm just going to be sauteing onions with olive oil. I'm cutting up all these onions in preparation, and I am crying. VOCs, man. This is my air quality detector, so I'm going to set it here on the counter, sort of near my stove. These are our baseline readings. Surprisingly, the particulate matter is 0 for both the 2.5 and the 10. And you can see our PM2.5 and our PM10 have come up a little bit, but they're still pretty low. They're still well within the like not dangerous, good air quality levels. So our PM2.5 is now up at 36, which is like reaching a level that's classified as unhealthy for sensitive groups. Is it because I'm burning them? Okay, so we're at 20 minutes of cooking these. All right, so now PM2.5 is 51, PM10 is 93. They're definitely elevated now that I've been cooking for 20 minutes. Like, this is not an unreasonable level of sauteing, and we have reached PM2.5 levels that are not super healthy. And now we're back down to PM2.5 of 3 and PM10 of 5. So what I'm gonna do is I'm gonna try the same test over again, but I wanna see if having the exhaust on makes a difference, sauteing onions for 20 minutes. This has only been going for like a minute, and the PM2.5 and the PM10 are higher. So this isn't a perfect test. Okay, so there's 7 minutes left in this test, but our PM2.5 is at 124, our PM10 is at 216. The vent is not doing as much as I had hoped. The exhaust fan is on. I have 2 windows open, and PM2.5 is 291, PM10 is 534, 525. Like, These are high. A note on range hood fans, by the way. Mine is not great. In fact, it's not even a vent at all, since it just recirculates the air back into the kitchen. So it's likely that it's going to make my particulate matter readings worse, since it's just moving them around in the space. Great, and I really do need to change the filter. I'll do that this weekend. No, I won't. But some hoods do vent outside, which is very helpful, and cooking on the back burners can help them trap even more particles. So you should do that. But particulate matter isn't the only potentially harmful thing produced when you cook on a stove, especially a gas stove. Some of the most concerning byproducts are nitrogen oxides. Nitrogen oxides are a mixture of nitric oxide and nitrogen dioxide. Nitric oxides can damage the respiratory system, exacerbate things like asthma, and lead to chronic lung disease. These are some of the real baddies of your gas stoves, and not like good baddies, like bad baddies. Nitrogen oxides are formed by 3 different mechanisms. The main one happening on gas stoves is thermal nitrogen oxide formation. In this, dinitrogen and dioxygen molecules in the air mix with the natural gas and then react with each other, usually in the hot air near the burners. This reaction can be written as the Zeldovich mechanism. And this kind of reaction just won't happen on an electric burner because you don't have an open flame to react with the surrounding air. There are 2 other mechanisms that can happen in gas stoves to put nitrogen oxides into your air as well. Prompt NOx formation, where nitrogen molecules in the air react with hydrocarbon radicals from the fuel, and fuel NOx formation, where nitrogen compounds from the fuel react with oxygen from the air. These contribute way less, though, than thermal NOx formation, and their reaction diagrams look like this. So it's complicated. Researchers have found higher concentrations of nitrogen oxides in homes that cook with gas stoves than in homes that cook with electric stoves. And remember, the EPA doesn't regulate indoor air quality, but the outdoor ambient air quality standard is 100 parts per billion for an hour. Just boiling water on a gas stove can cause concentrations inside a home to peak to over 180 parts per billion, and roasting meat in a gas oven can cause peak concentrations to hit almost 300 parts per billion. So that's way above the outdoor standards. And the American Lung Association states that not only are nitrogen oxides respiratory irritants, but nitrogen dioxide exposure has also been linked to cardiovascular harm, lower birth weight in newborns, and an increased risk of premature death. It's not good, nitrogen oxides. You're not good for us. The last gross gas byproduct we're going to talk about is carbon monoxide. Carbon monoxide can be toxic in high quantities, sometimes causing suffocation and death, and can potentially exacerbate cardiovascular issues in lower quantities. Carbon monoxide is produced when there's incomplete combustion of methane and oxygen, usually from insufficient oxygen for the reaction. So basically, that hydrocarbon combustion that we talked about before doesn't perfectly produce CO2 and H2O, but also yields some sort of half-formed products as well. And there are lots of reasons why this could happen in a household appliance. If the gas pressure is wrong, if the gas release hole is the wrong size, so maybe too much or too little gas is coming out, if there's stuff stuck to your burner, if there's too much air or too strong of a draft, etc., etc. Thankfully, a modern, well-functioning gas stove shouldn't produce a ton of carbon monoxide. It's really poorly working or poorly cleaned models that you have to worry about. But it is still really important to have a carbon monoxide detector in your home, especially if you use a gas stove. And by the way, the methane itself is a greenhouse gas. Any unburnt methane that leaks into your house is eventually going to make it out into the environment through a window or a door. And there's not an inconsequential amount that leaks into the atmosphere during transportation to your home as well. One estimate claimed that the methane emissions from gas stoves in the US alone are equivalent to the carbon dioxide released from 500,000 cars. And a recent Stanford study said that methane leaks out of your gas stove even when it's off. So just owning it is bad, even if you never use it. So what can you do? Well, replace your gas stove if you can. Cities across the US are starting to ban them in new construction. And if you can't do that, turn on the vent and open a window. And I know that it is loud, I hate using the vent, but at least it's keeping your home and your lungs just a little bit cleaner.